Good day, this is Professor Wills, CBMD PhD, and today's Thursday, November 18, 2021. It is 2:07 and 18 seconds, p.m. Eastern Standard Time. Today's research, fungal resistance. So let's hop to it here. The new approach can overcome fungal resistance to current treatments. Date November 17, 2021. Source, American Chemical Society. The current medications aren't particularly effective against fungi. The situation is becoming more challenging because these organisms are developing resistance to antimicrobial treatments, just as bacteria are. Now researchers report that they have identified compounds that tackle these infections in a new way by interfering with fungal enzymes required for fatty acid synthesis, potentially opening the door to better therapies. The superficial infections by Candida or other types of fungi can cause irritating but relatively minor conditions, such as oral thrush and athlete's foot. But invasive infections can result in debilitating and deadly diseases, such as cryptococcal meningitis and some hospital-acquired infections. More people are getting these infections because of the growing use of invasive surgery, implanted catheters, and immunosuppressive therapy. And some patients, such as those with severe COVID-19 or HIV, are especially susceptible to fungal infections. In addition, treatments can be toxic and often don't work, in part because of increasing resistance. The current targets for these compounds include molecules necessary for making fungal cell walls. Researchers began looking for potential therapies that could work through a different mechanism and thereby avoid the drawbacks of these drugs. The researchers zeroed in on fungal fatty acid, FA synthase, and desaturase enzymes, which are essential for the growth and virulence of human fungal pathogens. It has been difficult to devise a rapid chemical assay to find inhibitors for these enzymes, since it is hard to isolate the enzymes. So the team instead combined genetic engineering with a whole cell assay to screen thousands of small molecules. Although none of these tested compounds blocked FA synthase activity and Candida albicans cell cultures, 16 inhibited FA desaturase activity. A core-acyl hydrazine structure was found to be key to the activity of several of these molecules, which were effective even against drug-resistant strains of several infectious species of fungi, while showing little to no toxicity to mammalian cells. The researchers know that these compounds are promising leads for further development as antifungal agents. Good day, this is Professor Wills, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.